All right, welcome back. Today we get to prove a part of Theorem 2.2 having to do with the fact that if you add the zero matrix to any matrix, you automatically get that matrix back. So to get started, let's do a little bit of scratch work. All right. So in general, matrix A looks something like a bunch of entries, A12, A1n, A21, A22, A2n, etc. But the zero matrix is special because we know what all the entries are. We know that all the entries are just zeros. Right? So if we imagine adding these two things together, right, we're just going to get A11 plus 0, A12 plus 0, etc. Right? So ultimately we are just going to get the entries of A back. So maybe we can think of a slightly shorter way to do this. So another way to write A so that we can look at the individual entries is Aij. And then O we could write something like a bunch of zeros. Right. And then when we add these together, we'll still get each of these Aij's plus 0. So that might make our proof look cleaner. So let's go ahead and get started. Right. So let's go back and remind ourselves of the assumptions we have to make. So first off, if A is an m by n matrix is our hypothesis here. So we should assume that. So let A be an m by n matrix. All right, so next up after that, maybe we should introduce the notation that we thought about in our scratch work. So let's write A equal to the Aij's, where Aij is the entry of A in the ith row and jth column. Okay. All right. So next up, similarly, we wanted to write O. We can write OMN as just the zero matrix, and maybe we want to do m by n just to remind ourselves. And really we could use the same m by n notation up here for A if we want, if we're worried about remembering its size. All right, so now we're to the point where we can actually do the computing. We've set up all our notation. So compute A plus OMN. First off, we want to do the substitution that we were planning on. Plus O. So substitution. All right. And then we get to use our fact that we know how to add matrices, and we know that adding them is adding the corresponding entries. So definition of matrix addition. All right, but now we're in real numbers land. Once we've turned this into the entries of our matrix, we know that this is just Aij because adding 0 to a real number. Right. So again, in this class, we're going to assume we can do everything with real numbers, and now we're trying to extend it to doing it with matrices. Right. So last step, this is A by substitution again, just the reverse direction. And then we should add a period to say we're done with that sentence. So therefore, our concluding sentence, A plus OMN equals A. And we're done. All right. Excellent. So that's that proof. Have a good one.